Hello guys, so far in the chapter DC power supplies we have learned these topics. In case if you miss these topics, the links are available in the description. Today we will learn the block diagram of 3-terminal IC voltage regulator, that is LM340, and along with this we will learn the working of fixed and variable 3-pin IC voltage regulator. So let's start with the topic block diagram of 3-terminal IC voltage regulator. The block diagram of 3-terminal IC voltage regulator consists of 3 terminals. Terminal 1 that is connected to V in, terminal 2 that is the V out, and terminal 3 that is common, or we can say ground. Now let's see. The voltage regulator using LM340 IC is most used voltage regulator IC. As shown in the block diagram, the built-in reference voltage VREF derive the non-inverting input of the op-amp. Here is the diagram where V reference or reference voltage is derived the non-inverting terminal of the op-amp. There are many stages voltage gain for the op-amp used here. This makes the error voltage between the inverting and non-inverting terminal almost zero. In op-amp, at the input end there are two terminals. One is non-inverting shown by the minus sign, and another one which is one is inverting which is shown by the negative sign, and another one is non-inverting which is shown by the positive sign. So the error voltage between non-inverting and inverting terminal is almost zero. Thus the inverting terminal value will also be same as non-inverting terminal, that is VREF. So from this we can conclude that as the difference between inverting and non-inverting terminal voltage is almost zero, so we can say that the voltage at inverting terminal is equal to the voltage of non-inverting terminal, and at the non-inverting terminal we are giving reference voltage, that is VREF. Thus the current flowing through the voltage divider can be written as I is equal to VREF upon R2. Here is the voltage divider formed by the resistors R1 and R2. So current flowing in this voltage divider is given by VREF upon R2. So this is the block diagram of 3-terminal IC voltage regulator. In this diagram there is a pass transistor which we have studied in previous lectures, thermal shutdown and current limiting technique, a op-amp and a voltage divider. So let's learn about these things. The resistor R2 shown in the figure is not an external component connected to the IC but an internal resistor that is built inside the IC during the manufacturing. This whole is inside the IC. The whole thing which is visible here is inside the IC. Nothing is outside the IC. The R1, the R2, the op-amp, thermal shutdown and current limiting, pass transistor. These all are packed in a IC. Due to above conditions, the same current passes through R1. Thus, the output voltage can be written as Vout is equal to VREF R2 multiplied by R1 plus R2. This shows that the output of the regulator can be controlled by putting the desired value of R1 and R2. The IC has series pass transistor that can handle more than 1.5 ampere of load current, provided that enough heat sinking along with it. Now, what is heat sink? Heat sink means the one who sink the heat. That means when the IC is get heated, that heat sink will use to sink that external or extra heat, so that IC should not be damaged or it can work for a longer time. Like other ICs, this IC also has thermal shutdown and current limiting option. Now, in the previous lecture we have learned about the current limiting technique and options. Now, what is thermal shutdown? Thermal shutdown, it is a feature that will turn off the IC as soon as the internal temperature of the IC rises above its preset value. That means when IC is started to heating, so after a particular temperature the IC will automatically shut down or the IC will automatically turn off, and all the procedure which is running at that time will be off. Now, for LM340, the value of thermal shutdown is 175 degrees Celsius. Now, let's see the advantages of IC LM340. These regulators have only 3 pins. One is for unregulated input voltage. Here it is V in. Here it is V in, which came from filters. Second is for regulated output voltage. Here is the second pin across which we are taking the output. Third is the ground, or we can say common. Now, second, these can supply load current from 100 milliampere to more than 3 ampere. Small in size, inexpensive, easy to use, available in plastic of metal package. These regulators requires only a couple of bypass capacitors. Now let's see the types of 3-terminal voltage regulator ICs. There are 2 types of 3-pin IC voltage regulator. One is fixed and another one is variable. This is the diagram of fixed 3-pin IC voltage regulator. That is the first type. Now, as here in the advantages, we saw that these regulators requires only a couple of bypass transistors. Couple of means 2 bypass transistors are required. Now, why 2 transistors are required? These are work. Capacitor 1, what is the use of capacitor 1, what is the use of capacitor 2, we are going to learn now. Now, here as well we are having 3 terminals. Terminal 1 which derive the input, unregulated input. Terminal 2 will give us the regulated output, and terminal 3 is common, or we can say ground. So let's see about the fixed type 3-pin IC. Fixed 3-pin IC voltage regulator. LM340-5 can be used to provide a fixed output voltage of plus minus 5 volt, plus minus 2 volt. Here the pin 1 is the input pin, pin 2 is the output pin, and pin 3 is the ground pin. This IC provides good line and load regulation and has better ripple rejection. The output impedance is also very low, and it can derive maximum load current of around 1.5 ampere. The input bypass capacitor C1 prevents the oscillation, while C2 is used to improve transient response. Now, what is transient response? Transient means when the system is changing its state from rest position to its steady position. The time period which is taken by a system to reach to its steady state is known as transient time, and the response during that transient time is known as transient response. LM340-5 regulates over an input range of approximately 7 to 20 volt. Now what is input range? The unregulated input which we give at input terminal 1 is in the range of 7 volt to 20 volts. Any device in the LM340 series needs an input voltage at least 2 to 3 volt greater than the regulated output voltage. Now suppose I want the output of 5 volt DC, a constant 5 volt DC, or I can say a regulated 5 volt DC, and for that the input which we are going to give to the IC should be at least 2 or 3 volt greater. That means it should be at least 7 or 8 volt. Then we will able to get the appropriate output, or we can say a desired output. If we are not giving extra voltage or 2 or 3 volt greater than the regulated output voltage, then what happens? It will stop regulating, and this is called as brain out. Let's see the applications. To provide adjustable output voltage by using variable resistor, LM340 regulates positive output, and LM320 series handles the negative output. By combining 340 and 320, we can regulate the output of split power supply, as LM340 gives us positive output and LM320 gives us negative output. Now let's move to the last topic, that is the second type of 3-pin IC voltage regulator, that is variable type. Here is the diagram where LM317 is used, and this LM317 is known as variable 3-pin IC voltage regulator. In the above figure, variable voltage regulator using LM317 is shown. A bridge rectifier and capacitor input filter provides unregulated DC input voltage to IC LM317. Typically, the filter capacitor is selected to get a peak to peak of about 10%. Since regulator has 80 dB of ripple rejection, final peak to peak is about 0.001%. Now what is peak to peak? 10%, 0.001%, let's see. Now suppose if I want the output of 5 volt. So at the output of filter, as we have used capacitor input filter, so the output of filter is about 10% of peak to peak voltage. Now what is 10% of peak to peak voltage? For example, I required the output of 5 volt, so my value is 5 volt. Now the 10% of 5 volt, so here we go, multiplied by 10%, so I will get 0.5. So 10% of 5 volt is 0.5 volt. So I can say that at the input at the output of capacitor, the value of peak to peak is 5.5 volt. Now what is peak to peak? Suppose this is my waveform, AC waveform. Now peak to peak, that means for the positive half cycle the maximum peak value, and for negative half cycle the minimum peak value is known as peak to peak voltage. So this peak, for example, if this peak value is 230 volt and this peak has value of minus 230 volt, so we can say that for a AC input peak to peak voltage is 230 volt. Now, since the regulator has 80 dB of ripple rejection, final peak to peak is about 0.001%. So what is 0.001? So let's calculate the 0.001% of 5 volt. So it is 0.000005 volt. So my output will be in the range of 5.000005 volt, which is approximately equal to 5 volt. So we are getting the straight DC, a constant, or we can say a regulated DC. LM317 can provide 1.5 ampere load current over an adjustable output range of 1.25 volt to 37 volt. It provides good line and load regulation. The output equation is given by Vout is equal to 1.25 multiplied by R2 upon R1 plus 1. Let's see the applications. Maximum load current comparatively high as compared to the other voltage regulator. RC and LC filters are not required. These can provide output voltage of wide range. That's all about today's lecture.